Hello everyone, welcome back to this channel. So today we are going to do some numerical questions from probability. Okay, now first question is, what is the probability of getting a head when a fair coin is tossed once? See, before that, let me tell you the definition of probability. The definition of probability is number of favorable outcome divided by total outcome. Probability means chances of occurring any event. You are throwing a coin and you want it to become head. So what are the chances that you will get it as a head? Okay, not as a tail. That is what is probability. What is the probability of occurring a head? Okay. So now see, first question, getting a head when a fair coin is tossed. So when a fair coin is tossed, it will either be head or tail. So total number of outcomes is 2. But what is my favorable outcome? That is getting a head, and head will appear one time. So the favorable outcome is 1 divided by total outcome is 2. So the probability will be 1 by 2 or 0.5. Clear? Now the second question. A die is rolled once. What is the probability of getting a number less than 4? Die is rolled once. That means it can be 1, 2, 3, 4, 5, 6. Any number, right? So total number of outcome 6. So it will be 6. But you want a number less than 4. So your favorable outcome 3 or 2 or 1. So total 3. Okay, so any one from this is your favorable outcome and that will be on the top. Okay, so total number of favorable outcome divided by total outcomes, that is 3 by 6. Clear? This is how you calculate probability or chances of occurring any event. Now two events are independent. Independent event, that means A intersection B equal to PA into PB. Okay, they are not dependent on each other, they are completely independent. So they are occurring together is this PA into PB, this portion. This is A, this is B. Okay, so here PA equal to 0.5 and 0.4. So it will be 0.20. Okay. Now if the probability of an event is 0.65, so probability of A equal to 0.65. What is the probability of its complement? Complement means P of A bar, that is 1 minus P of A. So 1 minus 0.65 equal to whatever 0.35. Exactly opposite is the complement, right? Head is the complement of tail, right? Now next question. A bag contains 3 red, 5 black. See, red, black. 3 red balls, 5 black balls. And 1 ball is drawn at random. What is the probability? It is black. See, what is the total outcome? 8. Because 3 red balls, 5 black balls. So total outcome is 8. What is your favorable outcome? That is black. So any one from here. So total 5 blacks are there. So it will be 5 by 8. Clear? Now which of the following is a valid probability value? See, minus 0.1? No, it cannot be, because we know the value of probability will always be between 0 to 1. 1.2 not greater than 1. 0.8 yes. 1.5 not greater than 1. Clear? So 0.8 can be a valid probability value. Next one. A coin is tossed 3 times. What is the probability of getting 2 heads? See, one coin tossed 3 times. So first attempt it may be all of them are head, right? Second attempt it may be head, but this may be tail. All of them are thrown at the same time. Next maybe this is head but this is tail, this is also tail, right? Next time maybe this is tail but these are head. Maybe this is tail, this is also tail, this is head. Or maybe this is tail but this is head and this is tail. Same way again it may be head, it may be tail, it may be head, right? Or maybe all of them are tail. These are the total combinations, right? So 1, 2, 3, 4, 5, 6, 7, 8. So this is total 8. Or simply we can calculate that 3 times and outcome is 2. That means 2 to the power q. That is 8. For every scenario, either head or tail, right? And it is done 3 times. So that's why 2 to the power q. This is 8. So this is total number of outcomes. That will be here. Fine. Now my favorable outcome is what is the probability of getting exactly 2 heads. See, here it is exactly 2 heads? No. Here, yes. Here exactly 2 heads? No. Yes. No. No. Yes. No. See, 1, 2 and 3. Okay. So the favorable outcome is 3. So this will be answer 3 by 8. Clear? Whatever the question is. What is the probability of getting exactly 3 heads? 1 by 8. What is the probability of getting no head? This one. 1 by 8. So this way whatever the question is you can simply calculate. Okay. Next, if two events are mutually exclusive, then P A intersection B. See, they have already said that they are mutually exclusive. And what is A intersection B? A intersection B means the common part. This is A, this is B, this is A intersection B. But if they are mutually exclusive, that means A, B are completely separate. They can never touch each other, right? They are mutually exclusive. So this portion will not exist at all. So this is simply 0. Okay. Next one. If PA equal to 0.7, PB equal to 0.5, PA union B equal to 0.9, then what is PA intersection B? This is a very famous formula, you know. PA union B equal to PA plus PB minus PA intersection B. Right, I told you, A union B. That means the complete thing, right? That's what you want to calculate. So you have to take the whole of A, that is PA. You have to take the whole of B, that is PB. And you can see that this amount is calculated twice while taking A and while taking B. So you have to remove this once. So minus PA intersection B. And this portion you know it is intersection. That's what I have written here. Now here you just put the value 0.7 plus 0.5 minus this is 0.9 and this is PA intersection B. So you just do the calculation. Okay. Next question. In tossing two coins, the probability of getting at least one head. Okay. See, you are tossing two coins. So first one may be head, second one also may be head. First one head, second one tail. First one tail, second one head. Now first one tail, second one is also tail. Total. I have also told you are tossing two coins and each of them can either be head or tail. So outcome is also 2 times and you are tossing 2 times. So 2 to the power 4 will be total outcome. That is what is here. So 4. Now my favorable outcome. At least one head. At least one head? Yes. At least one head? Yes. At least one head? Yes. No. No head. So this is 3 out of 4. This will be the answer. Okay. This is also considered because it is told at least. Okay. Not exactly. Next one. A number is chosen at random from 1 to 10. What is the probability it is a prime number? See, a number chosen from 1 to 10. So total outcomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can choose any number from here, right? So total outcome is 10. What is the favorable outcome? That is prime number. 1, 1, 2 is a prime number, 3 is a prime number, 4 no, 5 is a prime number, 6 no, 7 is a prime number, 8 no, 9 no, 9 can be divisible, 10 no. So 1, 2, 3, 4. So total 4 out of 10. 2 by 5. Okay. Now if an event has the probability of event, what can be said about the event? Probability of 1, that means that will happen. Okay, whatever you do, that is a sure event. So I can write certain event. Okay. Now if a card is drawn from a deck, what is the probability that it is not a spade? Okay, for that you have to know about the cards, that how many are spade and other types of cards. So total we have 52 cards and among them 13 cards are spade cards. Okay, so you said that it is not a spade. So what is your favorable outcome? Other 39 cards. If I minus, then it will be 39 cards exactly. So your favorable outcome is not a spade. So any number from other 39 cards, and total you have 52 cards in a deck. So that is the answer. So now you can simply divide. It will be 3 by 4 divided by 13. Okay. Now, if events A and B are independent, then what is the value of P A union B? See, now you can do it. P A union B equal to P A plus P B minus P A intersection B, right? PA you know 0.6 plus 0.5 minus PA intersection B. You have said this is independent. When you say it is independent, that means PA into PB is the solution. So now here put 0.6 into 0.5. Okay, so you add them 0.11 minus 0.3, so it will be approx 0.8. Okay, that is fine. Now, what is the probability of getting a sum of 7 when two dice are thrown? See, first dice, let's say this is 1. Second dice, also 1. First 1, second dice 2. 1, 3, 1, 4, 1, 5, 1, 6. Right? First time. Now second dice 2, first dice 1. 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Or it may be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. I am taking the first as constant and I am taking all the values from the second one. Same way 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Same way 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And last 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So total 6 into 6 equal to 36. You can count 6, 12, 18, 24, 30, 36, right? Or you can simply calculate from here that you are throwing two dice, right? So first probable outcome is 6 different types, or you can say you are throwing two dice. You don't need to write these things, okay? For the first time I am just telling you that so that you can understand what are the probabilities. But two dice, so first one can be any value from 1 to 6, second one can be any value from 1 to 6. They are independent, so total 6 into 6, 36 types of events can happen. Okay, so this is total number of outcomes. Now, what is the probability of getting a sum of 7? Now tell me. Sum of 7? No, 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 yes. Sum of 7? No, no. 6, 7. Yes. No. 5, 6, 7. Yes. No. 7, no. 6, 7. Yes. No. No, no. 6, 7. Yes. No, no, no. So everywhere you can get one value. So total you can get 6 value. So 6. Okay. Or once you know these things, you can simply calculate by yourself that at least 1 with 6. Then only it will become 7. If the first one is 2, then 5 you need to become 7. If first one is 3, then you need 4 to become 7. If the first one is 4, then you need 3 from 7. If the first one is 5, you need 2 to make 7. First one is 6, then you need 1 to make 7. Right? So 1, 2, 3, 4, 5, 6. So total 6 favorable outcome can happen to get exactly a sum of 7. Simple. So the answer will be 1 by 6. Okay. If the question is something like getting a sum of 8, let's say, then getting a sum of 8 means you think that first one is 1. So if the first one is 1, then the second one have to be 7 to make it a 8, right? but that is not possible. 7 is not available, so this can be a solution. If the first one is 2, then the second one has to be 6. That is possible. If the first one is 3, then the second one has to be 5. That is also possible. If the first one is 4, then second one also has to be 4. That is also fine. First one is 5, then second one 3, 8. That is also possible. If the first one is 6, second one has to be 2, 8. That is also possible. And now first one cannot be 7. So I have total 1, 2, 3, 4, 5. So it will be 5 by 36. Same way you calculate what is the probability of getting a sum of 9, getting a sum of 10, okay, anything. Now, a number is selected at random from 1 to 100. What is the probability that it is divisible by 5? First of all, any number from 1 to 100, so total outcome 100. No doubt with that. But favorable outcome is divisible by 5. So, what are divisible 5? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? 55, 60, 65, 70, 75, 90, 95 and 100, right? You have to just multiply 5 into 1, 5 into 2, 5 into 3, 5 into 4, 5 into 5, this way. Now you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it will be 20 by 100, that is 1 by 5, okay? Okay, now the last question. Which rule allows you to compute P A intersection B when A and B are dependent? Okay, so first is Bayes rule. Let's understand what is Bayes rule. Bayes rule simply means what is the probability of occurring event A when event B has already happened. Okay, this is the past. This has already happened. So what is the probability of occurring event A? Okay, it's like what is the probability of happening, what is the probability of raining today when yesterday it has already rained, like this. So this is probability of event B given that A has already happened, exactly the opposite one, into probability of event A divided by probability of event B. Okay, so as per Bayes, this is the formula using which you can calculate what is the probability of occurring event A when event B has already happened. This is known as Bayes rule. Second one is addition rule. Addition rule we already know, PA union B equals to PA plus PB minus PA intersection B. We have already done some maths using this rule. Third one is conditional probability. Conditional probability means PA given B equals to PA intersection of B divided by PB. That is also a probability of occurring event A given event B. Okay, to calculate this, you can use this formula. This is known as conditional probability. So Bayes theorem is based on this conditional probability, right? Now the last one, multiplication rule for independent events. That means PA intersection of B equal to P of A into P of B. They are independent. So what is the solution? This is independent event, so this is not a question. Addition rule, that is also not. So to compute A intersection B, see this one, P A intersection B equals to P of multiplication of them, A given B into P of B, right? So the answer is conditional probability. Okay, so done for the day. Bye, happy learning.